is on trigonometry. So you're going to learn trigonometry not only in this class, but also a little bit in Algebra 2, and then a lot in pre-calculus. So trigonometry is something that's very, very important. It helps us to find the lengths of sides of a triangle and so on. So a trigonometric ratio is a ratio of the lengths of two sides of a right triangle. So the word trigonometry, if you think about the stems of that word, has anybody ever studied like Latin or Greek or anything? If you look at the stems, we have the word tri, which means what? 3. We have gon, which means like polygon, so a 3-sided figure. And then metry means measurement. So we have the measurement of 3-sided figures. So the measurement. And what do we call 3-sided figures? Yeah, so the measurement of triangles. That's what trigonometry means. We love triangles. All right, so trig ratios, you're going to see something called sine, cosine, and tangent. And what these ratios are is it relates two sides to one another. Okay, so you might relate one of the legs to the hypotenuse. Okay, so when we talk about angle A, we're going to talk about how the sides are related to A. So first of all, what about this side right here? What do we always call this side right here? Hypotenuse. So we know that. So this is the hypotenuse. Okay, now we have two other words that we're going to use. We're going to use adjacent and we're going to use opposite. Okay, so adjacent is going to be the one that's next to A, but not the hypotenuse. So do you guys see where the adjacent is? So it's next to A, but it's not the hypotenuse. And then opposite is going to be across the triangle from it. So going all the way across the triangle, this would be opposite. Now be careful, because if I talk about angle B has a different adjacent and opposite. So if I had angle B, then angle B's opposite would be this line, and angle B's adjacent would be this line. Does that make sense? Okay, so there's a way to remember the trig ratios, and we use the word Sohcahtoa. Okay, there's probably a politically incorrect story about this. There is a politically incorrect story. I'm not going to share this story, but that's the way I learned it in school. But we don't really do that anymore. So we have the word Sohcahtoa, and we have sine, which is opposite over hypotenuse. We have cosine, which is adjacent over hypotenuse. And we have tangent, which is opposite over adjacent. Okay, and that's what each one stands for. Do you guys see it? The SO is S-O-H. So you kind of break it into its 3 parts. So SO is sine of the angle. Sometimes when I talk about angles, I use thetas. Thetas look like a little O with a line there. So sine of some angle is equal to opposite over hypotenuse. So that's where the SO comes in, S-O-H. Do you guys get it? And then cosine of our angle is equal to adjacent over hypotenuse. So we have C-A-H. And then last one, tangent of our angle is equal to opposite over adjacent. So we have our T-O-A. Okay, so we're going to say this word several times. Okay, I want you to say Sohcahtoa 5 times. Are we ready? Okay, go. Sohcahtoa. All right, you have to know how to spell Sohcahtoa. So some of you guys get very creative in your spelling. There's 3 letters for each one, right? Those 3 letters are important to us. We need to know that so is S-O-H. It's not just S-O, because we need 3 letters, okay? Does this make sense? So Sohcahtoa. All right, so it says use a calculator to find the following to 4 decimal places. So you've probably seen on your calculator something that looks like sin, cos, tan. Okay, so we're going to do sine of 56, cosine of 84, and tangent of 16 degrees. Now, our calculators are very fancy, and they have multiple modes on it. Okay, so there's something that you learn in pre-calculus called Radian Mode. We're not going to use Radian Mode. We're going to use degree mode, because all of these are degrees, right? 56 degrees, 84 degrees. So I want you to hit mode. Mode is in the top next to your second button. And I want you to go down, and do you see where it says radian and degree? Make sure the degree is highlighted. Is degree highlighted for you guys? So some of you guys have these other calculators. Are you finding it? So it should say DEG on your calculator. So you can test whether or not it's correct by putting in sine of 56. When you hit sine of 56, and I said round to 4 decimal places on this, you should get 0.8290. Did you guys all get 0.8290?
Yeah.
Okay, if you did, then your calculator's in the correct mode. Are you good, Roman? Correct mode? Okay, so the next one, cosine of 84, what do you guys get? 0.1045, perfect. And then tangent of 16? Yep, 0.2867, perfect. Okay, so what that's doing is sine is relating opposite to hypotenuse, and so on. So on this number 2, I think it will make more sense to see them as fractions. So it says find the 3 trig values for angle A, so here's angle A. If C, so little c, so in a triangle, little c is across from angle C. So where would I draw the 15? The hypotenuse, right? So if you have angle C here, then going across the triangle. Okay, so across from A, you have little a, across from angle C, you have little c, and across from angle B, you have B. Does that make sense? We're always going to do that in geometry. So whenever you see like a little a, it's across from angle A. Okay. All right, so across from angle A, we have little a. Across from angle C, we have little c. So C is equal to 15. A is equal to 12. And we want to find the 3 trig values. So first of all, do we know what B is equal to? Can you guys find B? Find it. So we're going to find it. We're going to do 12 squared plus B squared equals 15 squared. Pythagorean theorem, because we have a right triangle. This is a Pythagorean triple. We end up getting B is equal to 9. It's a 3, 4, 5. Do you see that? 3, 4, 5. We had 9, 12, 15. We multiplied by 3s. So if you catch on to those, sometimes you can get it right away. So we have B is equal to 9. So if I'm talking about sine of angle A, cosine of angle A, and tangent of angle A, let's figure out what they are. So sine of angle A is opposite over hypotenuse, right? So our opposite is little a, which is 12. Our hypotenuse is 15. So that was opposite, and that was hypotenuse. So how does that reduce? Yeah, divide by 3, so we get 4 over 5. That's the trig ratio for sine. So sine is 4/5. Sine of that angle is 4/5. Cosine of A. Well, cosine is adjacent over hypotenuse. So what's the adjacent to A? 9. What's the hypotenuse? 15. So 9 over 15 reduces down to 3/5. So that's adjacent over hypotenuse. And then tangent is opposite over adjacent. So opposite is 12, adjacent is 9. So we get 4/3. Okay, critical thinkers, let's see if you can figure this out. So it says, will sine and cosine ever be greater than 1? Why or why not? Will tangent ever be greater than 1? So sine and cosine. So we just had 4/5 and 3/5. Are we ever going to have like 5/4, 5/3, something like that? Will it ever be bigger than 1? I see some of you shaking your head. No. Why? You're right. It can't be bigger than 1. Yeah, exactly. Do you guys get it? It's like opposite over hypotenuse or adjacent over hypotenuse for cosine, right? Hypotenuse is always the biggest. Sarkis, put your computer away, please. So you're distracting Max, I can tell. From where?
New Jersey.
Oh, great. Maybe it's Ian Weicker. Ian's from New Jersey. Just calling you. All right. Yeah. So sine and cosine are never going to be bigger than 1 because you're always dividing by the hypotenuse. Hypotenuse is always the biggest, right? So no. Opposite over hypotenuse and adjacent over hypotenuse are less than 1 because hypotenuse is big. I guess I'll say biggest. But will tangent ever be more than 1? Yeah, in that last example it was, right? Does that make sense? So tangent is the only one that can be more than 1. Not greater than or equal to, just greater than 1. So tangent can be greater than 1. All right, so let's do some problems here. So angle of elevation, it says when you look up at a point in the distance, the angle that your line of sight makes with a line drawn horizontally. Okay, so angle of elevation is when, let's say this is our little stick person. You have your line of sight that goes out horizontally. The angle of elevation is this angle right here. So if you're looking up at like the top of a tower or something, that's your angle of elevation. The angle like looking up to a tower or tree or whatever. An angle of depression is the angle that your line of sight makes with a line drawn horizontally. So angle of depression is when you're looking down. That would be angle of depression. Okay, your angle of depression is equal to the angle of elevation, and I'll show that to you in a couple of these examples. So it says the angle of elevation from the base to the top of a playground side is 55 degrees. So if I'm looking up at that slide, this angle is 55 degrees. So it doesn't always have to be looking up, but it can be like with the horizontal ground and going up. The slide takes up 10 feet of space horizontally along the ground. Estimate the height, so I'm going to call it h, and the length. So I know it's confusing because it looks like hypotenuse for h, but height and length. Okay, so we're going to do one thing at a time. So let's start out with the height. The only angle we have is at 55 degrees, right? So this is the angle we're using. Do we have opposite, adjacent, hypotenuse? So if I want to find the height, that's opposite, right? Because it's across the triangle. And I also want to use the number that I was already given. What number was I given? 10. Is that adjacent, hypotenuse? What is it? Adjacent. So the two things I want to use are the O and the A. So if you need to write out your Sohcahtoa, we want O and A. So which one do we want to use? The toa part, right? Tangent. So we're going to say tangent of our angle, 55 degrees, is equal to opposite over adjacent. So adjacent was 10. So h over 10. So that's how we set up our equation. Does that make sense? So tangent of 55 we can find on our calculator. So you do tangent of 55. So I get like 1.4281 equals h over 10. And then I multiply that 10 over. So I just take my answer times 10. And then in the end, we're going to round to 3 decimal points. So I'm going to say 14.281. Okay. So you really don't even need to write that intermediate step. Like if you don't want to write this part here, and you just want to find that and then multiply by 10, like find tangent of 55 and multiply by 10, like in the same step, you can do that. I would just do 10 tangent of 55 on your calculator. So it doesn't do like tangent of 550 degrees. Do you guys get what I'm saying? All right, so it says oh, I need to find the other thing. So now we want to find the length. So now if I want to find the length, what do I have? So the length is the hypotenuse. Do you think I want to use the h, which was 14.281, or do I want to use the adjacent, which was 10? I would use the adjacent again. And there's multiple reasons for this. First of all, I don't want to write all those numbers. But also, I've rounded with the 14.281, so I want a more precise answer by going back to that 10 from before. And what if you guys mess up? What if you get 14.281 wrong, and then you're using it in the second part of the question? Yeah, you don't want to do that. So we always want to go back to that original value if possible. So for this one, what am I using? I'm using adjacent and hypotenuse. So which one do I use? Cosine, right? So I'm going to say cosine of 55 degrees equals adjacent, which is 10, over hypotenuse, which is L. Okay, you guys go ahead and try to solve this. See if your L makes sense. So solve it out. Okay, so if I was going to solve this, I'm going to have to multiply the L over first. It's kind of like cross multiplication. Sorry, my 5s and s's always look the same. So I multiply the L over here. So I have L times cosine of 55. And I'm going to take that number, cosine of 55, and I'm going to divide it over. So you should have L is equal to whatever 10 divided by cosine of 55 is. So 17.434. So did anybody do it another way and get something that like just wasn't making sense? That happens a lot where people, they try to do like 10 times cosine of 55 or cosine of 55 divided by 10. And you'll end up getting something that doesn't make sense. It'll be like 0.1 feet. Well, that's not going to have a hypotenuse of 0.1, right? It's a slide. That would be the most boring slide ever if it was like 0.1 feet. You're like, okay, I'm done. Like, it's not fun. Okay, so make sure your answers make sense. All right. So you're measuring the height of a tower. You stand 154 feet from the base of the tower and measure the angle of elevation from a point on the ground to the top of the tower to be 38. So here's our tower. Yeah, I should make it look more fancy, like a princess tower, but you know. You stand 154 feet from the base, and you're trying to find the height of the tower, so h. So think about what we need. So write out Sohcahtoa. What do we think we need? Identify your angle. What do you have in relationship to the angle? You have adjacent. What else do we need? What are we trying to find? Ah, I wrote an H, but it's not for hypotenuse. Height, which is opposite, right? It's across the triangle from that 38. It's not the hypotenuse. So tangent of 38 degrees equals opposite over adjacent. So this is one where you can just multiply that 154 over. So we're going to do 154 times the tangent of 38. And you put it all in your calculator like that. So we get h is equal to, yep, 120.318. Perfect. Feet. Make sense? It's like Sohcahtoa.
Sohcahtoa.
It's a very weird word, I know. All right, so solving a right triangle. So whenever instructions say solve the right triangle, that means you need to find every single side length, every single angle. So you'll always have three things. So you'll have either two side lengths. No, I guess you'll only have two things. So you'll either have two side lengths and a right angle, which is three things. Or you'll have a side length and one of the acute angle measures. So as long as you have two things, you're good to go. You can solve the rest of it. What if I just had angles, though? Like what if I had, 20 degrees and 70 degrees? Can I solve that? Can I say how long these sides are? No, there could be lots of triangles that have those, right? So if you just have two angles, you can't do it. But if you have at least one side, you're good to go. You can get all the rest of it. So two side lengths or a side length and one of the acute angle measures. I guess I should say at least one side and another side, or at least one side and an angle. Okay, so this is where we're going to use what's called inverse sine, inverse cosine, inverse tangent. So look at your calculators. So on my calculator, inverse sine is above sine. It's usually above sine on all of them. Do you guys see how there's usually like a second button? Do you guys see sine to the -1? We read that as inverse sine. Okay, so if I'm trying to solve for an angle, if I'm trying to solve for an angle, and I know like how long something is, what I have to do is I have to do inverse sine of x equals a. It's kind of like dividing by sine, but we don't really divide by sine. So we get rid of the sine by like kind of taking it to the other side with an inverse sine. It's like the opposite operation. It undoes it. It's kind of like multiplication and division. They undo each other. Sine and inverse sine undo each other. So we're going to take it to the other side. That's an N, not sir. Okay, so the next one is going to be if I want to solve for y, I do inverse, or solve for a, I do inverse cosine of y equals a. And same thing here, inverse tangent of z is equal to a. Okay, so it makes more sense when we see examples. So it says find the value of the angle A. So it's saying sine of some angle. So the sine of some angle is equal to Okay, so if I want to find how big that angle is, I get rid of the sine by doing inverse sine. So it's kind of like, here's what it looks like. I get rid of it by doing inverse sine in front of both things. And then these would cancel out. Does that make sense? So what I'm writing is A is equal to inverse sine of 0.9205. Do you guys see what I'm saying? Yeah. Okay, so I'm going to do inverse sine. So second sine, usually. Okay, and tell me what you guys get. Yeah, 66.999. So since I said to the nearest tenth, we're going to say 67.0 degrees. And we put that 0 to indicate that we've rounded. It wasn't exactly 67. All right, so how about B? So I'm going to do this by doing inverse cosine of 0.13. So I get 82.530. So B is going to be 82.5, right? Does this make sense? Okay, find the next two. So what happened when you tried number 4? Did you try it?
I tried, yeah. I just saw that. I'm like, we can't do that.
It's true. It will say error. It will yell at you. That's why I put that one on there. All right. Inverse tangent of 11.425. What'd you guys get for C? 85.0. Did you guys get that? And then this last one, when you try it, inverse cosine of 1.620. So why it says there's something wrong there. Mine says error domain. Does yours all say error domain? And why is that? Because sine and cosine can't be bigger than 1. Okay, so he noticed that without even doing that. But if you get error, that's what's happening. Scroll back up. Yeah. So we'll write not possible. Okay, making sense so far? So we're going to try to solve the right triangles. So flip your page. We're going to try to find all the missing side lengths, all the missing angles. Can I flip? Turkey, she good?
Yeah.
All right, so why did number 4 have an error? Because sine and cosine are never greater than 1. All right, so it says solve for x and w, round to 3 decimals. Okay. So, what do I want to do here? Okay, so do you guys see some markings that indicate that we have an isosceles triangle? Yeah. So we're going to put a 43 right here. So that means on the right side of this triangle, I'm going to make it a little bit bigger. We have 5, we have x, and we have 43. Because we had these markings that indicated that our angles down there were the same. Do you guys see that? All right, so let's solve for x. So with this angle that's 43, I have opposite. What else do I have? Adjacent. Okay, so I need to find the opposite. So I'm using tangent. So I'm going to say tangent of 43 equals opposite over adjacent, like that. So I have 5 times tangent of 43. So I get x equals 4.663. We'll say that. All right, now we want to find w. Okay, so if we want to find w, we have to use that value that we found for x. So now we have the triangle that's on the left-hand side, and we have 43, and we have x was 4.663, and we want to find w. Now, when you go on in your future math classes, what would be nice is if you use that answer that you used before, like in your calculator, because I rounded that. It was 4.662575, whatever. I rounded it to 4.663, remember? I showed you that PowerPoint where the bridges didn't match up. So we want to be as precise as possible. So we're going to use that answer. So let's set up another equation. So we have tangent of 43 equals opposite 4.663 over adjacent, which is W. So I'm not going to do anything on my calculator right now. All I'm going to do is I'm going to multiply the W to the other side, so I get W times tangent of 43 equals 4.663. And I'm going to divide by tangent of 43. So I'm going to have that number in my calculator that I've rounded. So I'm going to hit divide by on my calculator, and it's going to take that answer from before, and I'm going to divide by tangent of 43. Does that make sense? So I haven't rounded it. What do I get? 5. Why do you think it's 5? Yeah, look at this picture. Think about your patty paper. If you have an isosceles triangle and you drop straight down so that these angles are the same, that ends up being a 90-degree angle there. And the W and 5 end up being exactly the same. Does that make sense? All right, so do we feel pretty good with Sohcahtoa? I didn't do one where we actually solve the right triangle. Those ones are here. So when you're solving a right triangle, you would need to find G, K, R, but you'd also need to find little g, little k, little r. And most of them you have already. So like, do you guys see how little r is equal to 7? Little k is equal to 10. What else do we have already? Yeah, we have 90. So we can put k is equal to 90 degrees. Now, some teachers are really picky. They make you do like measure of angle k. You can just write k. As long as you're using a capital letter, I'll know that that's an angle. Okay, does that make sense? And then how could I find little g? I could do Pythagorean theorem, right? I could do that. So if I was finding little g, I'm going to do 7 squared plus g squared equals 10 squared. So I get g squared equals 51. So g is going to be 7.141. Okay. And then how would I find an angle? So I want to do this since we haven't done one like this. So let's say I want to get angle R. They're not 45. It's close though, because it's like 7.1 and 7. So it's really close to 45. So this is where we use our Sohcahtoa. So let's say we want to find angle R. We don't know it, right? We want to find it. What two were I given originally? Adjacent, opposite, hypotenuse. What do I have originally? Opposite and hypotenuse. So what do I use with opposite and hypotenuse? Sine. So I would set it up and I'd say sine of angle R is equal to opposite over hypotenuse, like that. Which is sine of angle R equals 0.7 if you find the decimal. How do I get R then? Huh? How do I get rid of that sine? What's the opposite of sine? Inverse sine. So I do inverse sine of 0.7. And when you do inverse sine of 0.7, you get R is equal to 44.427. So now that I have R, do I have to go back and do another sine, cosine, tangent to get G? No, I just do 90 minus that answer, right? Because I already have 90 degrees, so the other two angles have to add up to be the other 90 degrees. So we get 45.573. That way they add up to be 180. Does that make sense? So that's how you would solve a right triangle. So you would use Sohcahtoa to find anything that's missing and so on.